All right, final exam review number 2, transformations. So this first one is absolute value with a twist. When do I do the absolute value? I'll do what's inside the brackets first, then the absolute value, then the remaining transformation. So what is going on here? There is a horizontal, it's next to the x, so everything's backwards, compression by a half. And you know what, why don't I zoom into this question a lot more since I can. That'll help you see things a bit better. Then I'm going to do the absolute value. Then there is a vertical expansion by 2. And then there is a vertical reflection. So I'll do the key points. I'll do this point, this point, this point, this point, this point. I might do this one too because I'm a little suspicious that some weird stuff's going to go on here. Start here. Horizontally compressed by a half, I'll be 1.5 to the left. Absolute value, instead of 1 down, I'll be 1 up. Vertical expand, 2 up. Vertical reflection, -2. That point ends up right there. How about this guy? Horizontally compress a half. Oh, live with it. Absolute value, +3. Vertically expand, +6. Vertically reflect, -6. That line's going to go yoink like that. Let's do this one here because it's an intercept. Horizontally compress, 0. Absolute value, +2. Vertically expand, +4. Vertically reflect, -4. Yoink. Let's do this one. Horizontally compress, 1. Absolute value, 0 high stays 0 high. Vertically expand, 0 high stays 0 high. Vertically reflect, 0 high stays 0 high. Yoink. How about this point right here? Horizontally compress, 1.5. Absolute value, 1 above. Vertically expand, 2 above. Vertically reflect, -2 above. Yoink. How about, let's do this point right here. Absolute value, you know what, let's do this point because it's going to be nicer. Horizontally compress, 2. Absolute value, 1 above. Vertically expand, 2 above. Vertically reflect, 2 below. You know what, I'm going to get a little horizontal line and it's going to stop right, let's see, 2.5, absolute value, expand, reflect. It's going to stop right there. That graph would be come down. That's a tough question. Absolute value with a twist. Reciprocal with a twist, also a very tough question. So what I'm going to do here is reciprocal. Then there's going to be a vertical expansion by 2, and then there's going to be a vertical reflection. I'll do my invariant points first. That's invariant. Vertically expand, it's going to become too high now, because when I take the reciprocal of 1, it's going to be 1. That's why it's invariant. So reciprocal stays where it is. Vertically expand, -2 high. Vertically reflect, +2 high. That point's going to end up right there. How about here? I would take, well, you know what? Let's do the invariant points. Here, again, reciprocal of -1 is -1. Vertically expand, -2. Vertically reflect, +2. How about right here? Reciprocal of -1 is -1. Vertically expand, -2. Vertically reflect, +2. In fact, I have a little horizontal line. I think this whole line ends up there. Now what? Well, an asymptote is an asymptote is an asymptote no matter what. So there's going to be a vertical asymptote right there. What about this point? I'm kind of curious. It's -3 high. If I take the reciprocal, -1/3. If I expand it, -2/3. If I reflect it, +2/3. It's going to end up right about there. And I think that gives me an idea for what's going to happen now. I think the reciprocal is going to dominate the expansions. The original was getting further from 0. This one's going to get closer to 0, but from the positive because it has been reflected. This is going to get closer to 0, but from the positive because it has been reflected. This shoots off to -infinity. It's going to shoot off to +infinity, but that expansion is going to make it shoot off even faster. The reflection is going to make it shoot off to +infinity. This shoots off to 0, So the reciprocal would shoot off to negative infinity. It's going to shoot off to positive infinity. That's a very tough one. I think you could just count on a plain old standard reciprocal. But hopefully this kind of jogged your memory for transformations. What else are you going to see on your final exam? Oh, another half-life word problem. A equals A0 times C to the T over P, where A is your final amount, 90 grams. A0 is your initial amount, 450 grams. The half-life is the period, 32 years. This question, they're asking me to find total time. My equation is going to look like this. 90 equals 450. Half-life, the growth rate is always 0.5. If they'd said doubles, the growth rate would be 2. If they said triples, the growth rate would be 3. If they said a percentage, it's 1 plus the percentage if you're increasing, 1 minus the percentage if you're decreasing by that percent. To the T over 32. Now what? What kind of an equation is this? It's an exponential. How do I know the variable is an exponent? I would like to get the exponent, but I can't get the exponent by itself yet. I can't go 450 times 0.5. That would be violating BEDMAS. What I can do is divide both sides by 450. 90 divided by 450 is going to be the same as 9 divided by 45. I think it's going to be 0.2, but let's double check. Yeah, it is. 0.2 equals 0.5 to the T over 32. Now what? Take the log of both sides. And when I do that, I'll get log 0.2 equals, the exponent moves to the front, and I'm going to draw a proper fraction, not a stupid half-sized fraction that's going to confuse me, because now I can clearly see what's on the top, what's on the bottom. To get the t by itself, times by 32, divide by the log of 0.5. T is going to be 32 log of 0.2 divided by the log of 0.5, which is, drumroll please, I don't know, 32 log of 0.2 divided by log of 0.5. 74.3 years. Years? Days? I'll check. 74.3. Did I say how many decimal places to go to? I didn't. Usually go to 2 decimal places. It's in years, because it said a half-life was 32 years. 74.30 years. Half-life. On your log section of your final exam is either going to be a half-life question or an exponential question. I did one like that, an exponential equation on the last review, or a logarithmic equation, kind of like this. How do I solve this? I want to write this as one thing equals one thing. Are my bases the same? Check. What's adding 2 logs the same as? Multiplying. I can write this as the log base 2 of x times x minus 6 equals 4. Now, if this was a log on this side, if this said, for example, instead of a 4, instead the log base 2 of 12, well, then I'd be able to cancel out the logs, and I'd have x times x minus 6 equals 12. Unfortunately, I don't have a log on both sides. So instead, I have to rewrite this as an exponent. What to the power of what equals what? 2 to the power of 4 equals what's inside the log. 16 equals x squared minus 6x. What kind of an equation is this? It's a quadratic. How do I know? It's got a squared in it. What do I do to solve a quadratic? First thing, make it equal to 0. I got some grade 11 students in the room right now that just learned how to solve quadratic equations, and they're smiling at me going, really? You do that in Math 12 too? Yes, you do. You get x squared minus 6x minus 16 equals 0. This puppy factors. Woohoo! It factors into x minus 8, x plus 2 equals 0. What are the roots? 8 and negative 2. Go back and check the original question. You might have an extraneous root, and as it turns out, I think I do. That's assuming I can get my computer to move here. Oh boy, that doesn't look good. I hope that didn't just happen. Let's let it save first. Bear with me, folks. Old computer. Boy, if the writing became all smudged like that, I'm going to be a little frustrated because I just hit save. It's still saving. Let's try going close. Let's try bringing it back. Hey, there it is. Now let's look at the original equation. Can I put a -2 right there? No, because I can't take the log of a negative. So, much like when Trevor phones up somebody for a date, reject. Yes, Trevor, I made fun of you one last time. So that's review number 2. I have a couple of more reviews for you to work through. Again, if you want a good review, work through the 4 provincial exams that I gave you, especially the written sections.